Hello everyone and welcome to the lecture on AWS Internet of Things IoT Core. So this lecture will contain all these topics. What is AWS IoT? Supported protocols, IoT devices, AWS IoT architecture, AWS IoT device software, control services, data services, AWS IoT core messaging services, custom authentication service, device provisioning service, group registry, job service, registry, security and identity service, AWS IoT core data services. So what is AWS IoT? AWS IoT Core is a fully managed cloud platform designed specifically for Internet of Things applications, making it easier to develop and deploy IoT solutions. The platform enables connected devices to interact and communicate with each other and with cloud applications securely, ensuring data protection and privacy. AWS IoT Core is built to scale, capable of supporting a vast number of connected devices and processing trillions of messages efficiently. The platform processes and routes messages from devices to AWS endpoints and other devices reliably, ensuring smooth data flow and minimizing data loss. With AWS IoT Core, applications can continuously track and communicate with all connected devices even when they are not actively connected, enabling seamless IoT functionality. Supported protocols. First one, MQTT, message queuing and telemetry transport, which is a lightweight messaging protocol that allows devices to publish messages to a topic and subscribe to receive messages from topics. MQTT over WSS, which is for secure web sockets. This protocol provides the functionality of MQTT over WebSocket Secure WSS, which allows for real-time bidirectional communication with enhanced security. So socket is something like a bidirectional tunnel and secure means it will be secure. So communication will be secure. Then HTTPS, which is for Hypertext Transfer Protocol Secure, is supported for devices and clients to securely publish messages to AWS IoT Core. Then LoRaWAN, which is for long range wide area network, is a protocol designed for low power, long range wireless devices, ideal for IT applications that require extended battery life and wide coverage. Message Broker supports MQTT over WSS and HTTPS. The AWS IoT Core Message Broker is a key component that handles communication using MQTT over WSS, HTTPS protocols, enabling devices and clients to publish and subscribe to messages. Then AWS IoT Core for LoRaWAN is a specialized service that helps connect and manage LoRaWAN devices, eliminating the need for users to develop and operate their own LoRaWAN network server, LNS. So these are basically four major protocol, but there are two components. One is message broker for all this and one for LoRaWAN to handle only LoRaWAN protocol. Next is IoT devices. So on your screen you can see a list of IoT devices. This is just an indicative list. This is not the complete comprehensive list. So new IoT devices come every day and this is growing at a very rapid pace. So something like IoT Alexa, Echo, Fire TV, IoT sailboat, IoT sensor, IoT Think coffee pot, car, camera, bicycle, bank, cart, humidity sensor, industrial PC, door lock, Think factory, house, PLC, IoT Think utility, travel, medical emergency, light bulb, IoT Think temperature, humidity sensor, IoT Think police emergency, vibration sensor, wind farm, thermostat, stack light, and IoT Think temperature sensor. So this is the AWS IoT architecture. So there are three major layers. So first is the device software, second control services, and thirdly data services. So I'll be going over one by one. So starting with device software. So AWS IoT device SDKs connect devices to AWS IoT with open source libraries guides and samples for various hardware platforms. So IoT device SDKs offer this functionality. Then AWS IoT Device Tester, which automates testing of microcontrollers to ensure compatibility with free RTOS or AWS IoT Greengrass and AWS IoT services. AWS IoT Express Link, and this powers hardware modules with AWS validated software for secure, fast cloud connectivity, and it integrates with all AWS services. AWS IoT Greengrass, and this extends AWS IoT to edge devices for local data processing, machine learning, and secure communication, and it builds edge applications with pre-built software modules. Then FreeRTOS, which is open source RTOS for microcontrollers, supporting low power devices in IoT solutions, and this connects devices to AWS IoT and supports edge devices running AWS IoT Greengrass. And RTOS stands for real-time operating system. Next layer is control services, which is above the device software. And here we have what we are studying in this lecture, AWS IoT Core, which is a managed cloud service for secure interaction between devices and cloud applications. It supports many devices and messages, routing them to endpoints and other devices. It allows application interaction even when devices are offline. AWS IoT Core Device Advisor, which is a cloud-based test capability for validating IoT devices during development. It provides pre-built tests to ensure reliable and secure connectivity with AWS IoT Core before production deployment. Thirdly, AWS IoT Device Defender, and this provides it secures IoT devices by continuously auditing configurations for security best practices. It alerts when it detects security risks such as shared identity certificates or revoked certificates which are trying to connect. And lastly, we have AWS IoT Device Management. It tracks, monitors, and manages connected device fleets. It ensures device works securely post-deployment. It provides secure tunneling for access. It monitors health, troubleshoots remotely, and manages software and firmware updates. So this is part of control services. And last, we have the data services, which we can say some kind of a backend. So first one, Amazon Kinesis video streams stream live video from devices to the AWS cloud for storage, encryption, and indexing. Capture video data from sources like smartphones, security cameras, and drones. Enables live and on-demand playback. Integrates with Amazon Rekognition Video for computer vision and video analytics. It supports non-video data like audio, thermal imagery, and radar. Next is Amazon Video Stream with WebRTC. Provides managed WebRTC for live media streaming and two-way interactions between IoT devices and WebRTC compliant players. No need to manage WebRTC infrastructure. Build applications for peer-to-peer media streaming and real-time interactivity. Thirdly, AWS IoT Analytics. Runs sophisticated analytics on unstructured IoT data. Filters, transforms, and enriches data before storing it for analysis. Supports SQL queries and machine learning. AWS IoT Events. Detects and responds to patterns in IoT sensor data. Monitors data from multiple sensors and integrates with the AWS IoT Core, IoT Sitewise, and DynamoDB for early detection and insights. AWS IoT Fleetwise. This collects and transfers vehicle data to the cloud in near real time. It standardizes data format for analysis. Define data collection schemes for vehicles. AWS IoT Sitewise, and this collects, stores and monitors data from industrial equipment via MQTT messages or APIs. It uses a gateway to connect on-premises servers to the AWS cloud. So we have Fleetwise, which is for vehicles, and Sitewise, which is for factories or industries. Then AWS IoT Twin Maker, and this builds digital twins of physical and digital systems. It creates visualization using data from sensors, cameras, and applications to monitor operations, diagnose errors, and optimize performance. Okay, now we'll see AWS IoT Core Messaging Service. So that was the layer which is at the higher level what we have seen. We have device backend services, we have control services, and we have device software. Now we are looking at the lower level information like core messaging services. So what are the components that forms the core messaging services? First one is, so AWS IoT Core Messaging Service provides secure communication with IoT devices and manage the messages that pass between them and AWS IoT. So following are the key concepts. First one, device gateway. This enables devices to securely and efficiently communicate with AWS IoT. Device communication is secured by secure protocols that use X.509 certificates. Next core messaging service component is message broker, and this provides a secure mechanism for devices and AWS IoT applications to publish and receive messages from each other. You can use either the MQTT protocol directly or MQTT over WebSocket to publish and subscribe. Devices and clients can also use the HTTP REST interface to publish data to the message broker. The message broker distributes device data to devices that have subscribed to it and to other AWS IoT core services such as the device shadow service and the rules engine. Next one is AWS IoT Core for LoRaWAN. So this makes it possible to set up a private LoRaWAN network by connecting your LoRaWAN devices and gateways to AWS without the need to develop and operate a LoRaWAN network server (LNS). Messages received from LoRaWAN devices are sent to the rules engine, where they can be formatted and sent to other AWS IoT services. Rules engine. So this connects data from the message broker to other AWS IoT services for storage and additional processing. For example, you can insert, update, or query a DynamoDB table or invoke a Lambda function based on an expression that you define in the rules engine. You can use an SQL based language to select data from message payloads, then process and send the data to other services such as Amazon Simple Storage Service S3, Amazon DynamoDB, and AWS Lambda. You can also create rules that republish messages to the message broker and on to other subscribers. Okay, next we'll see AWS IoT Core Control Service, which provides device security, management, and registration features. So the key concepts are, so this is core control service. What we have seen earlier was the core services. This is part of the control, controlling different aspects of devices. So first one is custom authentication service. So you can define custom authorizers that allow you to manage your own authentication and authorization strategy using a custom authentication service and a Lambda function. So this is required. So how your device connects, you want to make sure that they are authenticated. So otherwise anybody can connect to your network. So you can put some kind of scheme and you can define custom authorization and have a Lambda function. So custom authorizers allows AWS IoT to authenticate your devices and authorize operations using a bearer token authentication and authorization strategy. Custom authorizers can implement various authentication strategies. For example, we have JSON Web Token verification or OAuth provider callout, and they must return policy documents that are used by the device gateway to authorize MQTT operations. So this will be the first step. So you will have to have a custom authorizer or some inbuilt authorizer. Next one is device provisioning service, and this allows you to provision devices using a template that describes the resources required for your device, which can be a thing object, a certificate, and one or more policies. A thing object is an entry in the registry that contains attributes that describe a device. Devices use certificates to authenticate with AWS IoT. Policies determine which operations a device can perform in AWS IoT. The templates contain variables that are replaced by values in a dictionary map. You can use the same template to provision multiple devices just by passing in different values for the template variables in the dictionary. Next we have group registry, and group registry allows you to manage several devices at once by categorizing them into groups. Groups can also contain groups. You can build a hierarchy of groups, so you can it's possible to have nested groups. Any action that you perform on a parent groups will apply to its child groups. The same action also applies to all the devices in the parent group and all devices in the child groups. Permissions granted to a group will apply to all devices in the group and in all of its child groups. And lastly, we have the job services. Allows you to define a set of remote operations that are sent to and run on one or more devices connected to AWS IoT. For example, you can define a job that instructs a set of devices to download and install applications or firmware updates, reboot, rotate certificates, or perform remote troubleshooting operations. To create a job, you specify a description of the remote operations to be performed and a list of targets that should perform them. The targets can be individual devices, groups, or both. So we have registry also, and this organizes the resources associated with each device in the AWS cloud. You register your devices and associate up to 3 custom attributes with each one. You can also associate certificates and MQTT client IDs with each device to improve your ability to manage and troubleshoot them. And lastly, security and identity service. And this provides shared responsibility for security in the cloud. Your devices must keep their credentials safe to securely send data to the message broker. The message broker and rules engine use AWS security features to send data securely to devices or other AWS services. So to summarize, we have to have authentication, we have to have authorization, and we have to have some kind of device management, remote device management, which you will be doing it through AWS IoT Core device provisioning component. And then you have group registry, how you manage multiple devices, because you will have millions or maybe thousands of devices that you have to manage. You have to group them. So if you are a big company, let's say you are distributing software to your remote TV or Android TV, how you will handle that. Or if you are like not only TV, you have some other equipment as well, like light bulbs, coffee pots, and also you have firmware updates and all, how you manage. So you will have group registry. Then you have jobs. Jobs basically is to remotely manage them, manage them in the sense like you will have firmware updates and all those things. Then registry, where you will have some kind of data and attributes to further organize them. And finally, you have security and identity. So how you will authenticate the services, and how will you do data transfer, such as certificate management, all those things, and rules engine. So these all will be part of a complete life cycle of managing devices or to control the devices. So they become part of the core control services. Now let's see AWS IoT Core data services. So AWS Core data services, the AWS IoT Core data service help your IoT solutions provide a reliable application experience even with devices that are not always connected. First component, one of the major components is a device shadow, which is a JSON document used to store and retrieve current state information for a device. So even when their devices are offline without any internet connectivity, it keeps a shadow, which is a JSON document, and it will synchronize when it comes online. Then to facilitate that, there is something called as device shadow service, and this maintains the device state for communication with applications online or offline. manages data for offline devices and synchronizes state upon reconnection. Devices can publish their current state to a shadow for use by applications or other devices. Because this particular service, and because you have something on your device and something on the cloud, and they must be sync. So when it sync, there will be like some kind of merge also may happen. Like if in case you have pushed some update and there is something which has come from the device, so it must have a merge or reconcile or whatever, and this will be a service that will be like a intermediary, like a mediator between the your offline device and the actual what is stored in the cloud for the device. And that's all. Thanks for watching.